Our next speaker is Lorenzo Pivetta. He graduated in electronics engineering and has been working on particle accelerator control systems for almost 20 years. He was formerly head of the controls at Electra and recently joined the SKA organization to contribute to the design of the control system architecture for the SKA telescope, and he's the control system domain expert. He's going to talk about the SKA telescope control system guidelines and architecture.
Okay, thanks for the introduction, and good morning, everybody. So this talk is going to be about a work which has been done for drafting the guidelines for the SKA control system and some architectural partners as well. So it's basically why this work. So the SKA is an international project currently counting 10 member countries, but in fact more than 100 organizations belonging to some about 20 countries participating in the original preliminary design and down contributing to the critical design. So it's a large worldwide community with different backgrounds and with different approaches to solve the control system problems. So an effort has been put in place since spring 2015, trying to standardize first and harmonize then the efforts, which turned out to be the adoption of the Tango framework. And what the control system guidelines are, basically, they are composed by the set of 3 documents. A main document is called CS guidelines itself. A second document which contains the SKA Tango developers guidelines for people who's going to develop the Tango devices for the SKA control system. And the third one is drafting the naming convention for the whole telescope, plus some additional technical notes which complement the previous document, which nowadays are at various levels of completion, so basically. These guidelines are the result of the effort by a group of people, of course, and they are intended to be working documents, so they may evolve with the project itself. And the purpose is basically this control system harmonization all across the SKA telescopes, thus identifying common approaches for monitoring and control, as well as generic design patterns to be applicable, identify the preferred Tango design patterns and avoid anti-patterns in order to maximize the benefits of adopting the framework, and also the preferred architectures to be applied to the SKA control system. And the guidelines also provide a template to document the interface between the elements and the telescope manager itself. The SKA, in fact, will be composed by 2 telescopes. More on this on the status report on Friday. One for mid-frequency and one for low frequency. The first one is going to be built in South Africa, the second one in Australia. And each telescope is in fact composed by a number of different skull elements. So the dishes, the central signal processing, science data processor, the infrastructure, aperture arrays, and so on. And each element will be basically in charge of one Tango facility. Typically, just one, with the interesting exception of dish, which as per current design is going to provide one Tango facility for each dish, resulting in some 170 facility for the SKA1 phase and more than 2,500 for the SKA2, which is an interesting number. In addition, the scope and responsibilities for each monitoring and control of the elements has been defined with respect to the central telescope management, this means that basically the top-level hierarchy of Tango devices has been standardized, and also the patterns for operating the telescope, so controlling the telescope during normal operation, or the patterns for aggregation and rolled-up monitoring and reporting, for the archiving, for the logging, for the alarms, and also for drill-down diagnostics and reporting. Since the nature of the project, which is very distributed, some clarification about terminology were worth, and basically some terms which are very common in control systems, such as monitoring, archiving, logging, has been clarified with respect to the Tango framework, in fact. And one additional interesting is the definition of alarms. The project decided to adopt a standard, an IEC standard, for managing the alarms, but the standard brings in a quite restrictive definition of alarms. It's basically requiring operator intervention, which does not place very well with the Tango concept of attribute alarms. So basically, alarms has been distinguished into three categories. The first one are Tango attribute alarms, which may not be compliant to the standard. And then element or telescope alerts have been introduced, which will consist of any aggregation of input values for whatever kind of, which may result in notification that may not require operator intervention. And then the telescope alarms which will be compliant to the standard. Also, an effort has been put to define what has been called the SKA control model, which is basically a set of common attributes to be used by all the devices with respect to the Tango state, basically. And some of the interactions for the SCM attributes has been drafted as well. For instance, how the health states of a component has to be computed with respect to its own and possibly the children components, or how admin mode is going to affect the Tango state, etc. The SKA project adopted a subset of the 14 Tango device states, and so a state machine has been proposed as well in order to provide a base for SKA Tango devices, taking into account the interactions with the additional SKA control model attributes as well. And this is the big picture, basically. Making evident, the telescope facilities, one for mid, one for low, and one of the element facility, and putting the attentions basically on what has been called element level devices, which are going to be standardized overall the telescope. Yeah, I mean, the current effort does not focus on the element hierarchy, lower level devices. This is not the purpose and the scope. So there are patterns, policies defined for the element masters called element master device, which is basically going to provide the standard paths for operational monitoring control on normal operations, the logging services, and just-in-time logging is flowing through the Tango logging services, whilst log storage for fault finding or diagnostic purposes is going to be implemented via rsyslog and Elasticsearch, basically. And the patterns for alarm handling at both element level and telescope level has been defined and drafted, and the ones for archiving I mean, engineering data archiving as well. So it's basically, overall, the telescope level, the project decided to use the HDB++ featuring the Cassandra backend. And the second volume is the developers' guidelines, which include a number of suggestions and aspects useful for the SKA Tango device developer, which means element and device modeling, or class documentation, configuration of the database, and goes into some device implementation aspects as well, including states, polling, attribute events configuration and requirements, alarms, the quality factor management, which is going to be mandatory for SKA Tango devices, archiving, how to deal with the unsolicited information, or how to report command progress for long-lasting executions, etc. A naming convention has been proposed as well for command attributed properties, and especially for the element level devices. And the third volume is about device naming convention, and this is going to apply to the whole telescope. So basically, it mandates that each name will be globally unique overall the observatory, which means both low and mid-frequency telescopes. The names will be managed on a central place, and the names for the SKA Tango facility have been defined as well. We went through a few slides ago. But also, there are some suggestions about how to write the names of the Tango devices, and a number, in principle, a finite number of controlled number of domains, as in domain family member. I mean, the triplets specifying Tango devices will be available. So where to get the CS guidelines? The revision 2 is going to be released very soon of the main document, whilst the technical notes are various levels completion. So some technical notes have been drafted quite a few months ago, and they may require some revision and reworking. So let me thank all the people which worked and contribute to the CS guidelines, and thank you for attending.